Hello and welcome to this short clip having a look at how to predict intermolecular forces from the structure of a molecule and link this to its likely boiling point. So if we think about intermolecular forces, in all simple covalent compounds, London forces take place between neighbouring molecules. In addition, if there are permanent electronegativity differences between bonded atoms within that molecule, you will get permanent dipole-dipole interactions. If specifically you have H bonded to F, H bonded to O, or H bonded to N, and there is a lone pair, at least one lone pair on the fluorine, the oxygen, or the nitrogen, you will also get a very strong permanent dipole-dipole attraction called a hydrogen bond. So going from left to right is an increasing strength of intermolecular force. So this question asks you to compare prop-2N1-ol, C4H10 butane, and propanone, CH3COCH3. So they all share the same relative molecular mass. It gives you the structures of the molecules and asks you to rank the molecules in order of increasing boiling point, explaining in terms of intermolecular forces why you've chosen this order. So let's look at them more closely first of all. If we go to the prop-2N1-ol molecule, you can see there's an OH bond, which is polar. I've put the dipoles in so you can see them. So this would exhibit hydrogen bonding, but only because it's got an oxygen and it's bonded to a hydrogen. In butane, there's no such polar bonds, so therefore there's only London forces in place. In propanone, you've got a polar bond, so that means it's a permanent dipole-dipole attraction this time. So it's not a hydrogen bond because it's a carbon bonded to an oxygen, not a hydrogen bonded to an oxygen. And furthermore, you're going to have London forces taking place in the pink shaded parts of the two molecules on either side. So you're going to have London forces in the background for all of them, but only London forces in butane. So let's try and pull all this together and rank them in order of increasing boiling point. So the order is butane is the lowest boiling point, then propanone, then prop-2N1-ol. So all three molecules exhibit London forces, but because they're of similar molecular size, which happens to be 58 grams per mole, and therefore similar numbers of electrons, this alone will not account for the differences in boiling point. So the hydrogen bonds in prop-2N1-ol are stronger than permanent dipole-dipole attractions in propanone, and in turn, those permanent dipole-dipole attractions are stronger than the London forces in butane. So finally, you need to connect this difference in strength to boiling point. So the stronger the intermolecular forces, the more energy needed to overcome them, and therefore the higher boiling point. Okay, I hope this has been a useful look at how we can drill down into different molecules and from their structures and the atoms present, decide what types of intermolecular forces are present, and from this, predict their relative boiling points compared to each other. Until next time, thanks for listening, and see you soon.